Welcome back, everyone. This video is going to demonstrate best practices on spot weld and continuous weld grinding and panel removal. As with any job, the first step is always cleaning the panel. So that's what the technician is doing right now, is performing a very thorough job at cleaning the panel before proceeding to any of the next steps. The technician has already researched all of the OEM repair procedures for this task, and he's already compiled the paperwork necessary for that. So here the technician is consulting that paperwork one more time, verifying the correct locations for this particular splice. He's making sure that he's noted any particular details in here, such as the exact locations and anything else that may be detrimental to this repair. So now he's taking a measuring tape and he's going to carefully mark and locate where the splice joint is going to be. Now if you notice, he's spending extra care and spending extra attention making sure that he gets it in the correct spot, marking multiple locations. He'll then continue to mark this and use a piece of tape to note where he's going. So now that the technician has carefully marked the location of the splice, he has taken a piece of tape and marked that location with a straight line so he can cut against the tape. As the old adage states, measure twice, cut once. So the technician is remeasuring that tape to ensure it is in the exact correct location, otherwise he'll reposition it. A good tip here is to take a pen like this technician is doing with that marker and mark on the tape which side to cut from. The next step in the repair process is to locate all the welds. Now in this instance, the welds are actually easy to locate, so we don't need to do any grinding. But if it were difficult to find, for example, covered in gravel guard, you could take a grinder like this and lightly skim over the surface, which can help highlight each of the factory spot welds. It's a good idea to go and put a mark in each weld to locate them for later, as we can see here. Now the technician is using a center punch to mark the center of the weld. And he's then taken a 1/8 inch drill bit to start the weld, as he's going to continue with a conventional 5/16 or 8mm drill bit to drill through this panel. Now the technician has the 8mm or 5/16 conventional drill bit in. You have to be careful because you have to drill through both panels with conventional drill bit, and in this case the technician did not check what was behind and caused damage to this fuse block. Now the technician has switched to a 5/16 or 8mm spot weld drill bit that will better allow the technician to only drill through one panel instead of both. It's also a good idea to place something behind the panel, such as a block of wood, to prevent damage in case you accidentally drill through all of the layers. Another option similar to what the technician just used is this spottle tool, which uses a similar spot weld drill bit attached to a specialty tool that allows leverage to be applied to the spot weld. Now the technician is going to use a cutoff wheel to remove these spot welds. Note how the technician has a face shield on and is still wearing safety glasses, the appropriate PPE. Using a cutoff wheel is an excellent option to quickly remove welds if you're using the medium or larger thickness of cutoff wheel in the tool. Look for a dark ring around your cut opening, and that will indicate that you've cut through a layer. Each layer will have a dark ring as you cut through them. If you are using this process, or as we're about to see the belt grinder, these are only used if the panel is not to be reused, as they do damage the panel. So as you can see, we're taking this belt grinder without using the tip, but slightly on the side rather. We are grinding this particular weld out and also looking for a dark ring around the weld. As seen here, a chisel or seam splitter can be used to carefully separate the layers of the panels. The technician is inserting the seam splitter and gently tapping his way through. If the panel is not coming apart with a few easy taps, it may be worth going back and doing some more drilling or grinding to completely remove the welds. Here he's coming in from the end of the panel as well to try and get the corner of the panel up. At this point, the technician has taken the cutoff wheel with the thin or narrow disc, and he's trying to cut the panel where the separation mark is while making sure not to overcut. So he's keeping as close to that line as he can without going over. He can always go back and trim. At this point, he's performing what's called a plunge cut, which utilizes the belt grinder. He's inserting the belt grinder until he goes all the way through the panel, creating a hole, and then he can take the belt grinder and move backwards into the pinched weld area, and that can allow the technician to grind that panel flat without causing damage to the inner panels. So the technician is through here. He did get a little off the line, but can go back with the belt grinder to complete it. But you see the inner panel is undamaged. Now the technician is at the bottom of the rail, and he's going to cut the rest of the seam, being very careful not to cause damage to the inner. So this is a different technique where he's going to do as much work as he can with the cutoff wheel, being careful not to overdo it by cutting any inner panels that may be hidden or going too deep into the pinch weld area. Once the technician gets to the point where he's about as deep as he can without causing damage, he's going to switch to using a chisel and use the chisel to finish off the rest of the cut for a clean cut that does not cause any inner panel damage. So now the panel is easily removed, and you can see where that joint is that the technician did not cause any damage whatsoever. Now the technician is going to grind this plug weld. He is going to use this angle grinder with 50 grit disc on it. You could use a 36 grit disc if there is a large weld or large area to be ground, and then transition to a 50 grit disc once about 80 to 90% of the grinding is complete. Afterwards, the technician is going to transition to a fiber disc, as we'll see in a few moments. Note how the technician is using the edge of the grinder and trying to focus that on the weld itself while avoiding the panel around the weld, which could overgrind and thin the metal, weakening that area. Now the technician is going to grind the weld on this butt joint. It's important to note that in this section of the video we have sped the time up so it's twice as fast, and with that you will hear that the grinder is moving quicker than it actually is. So it's a good point to note now that when grinding or using the drill, low speed is best. Try to use the tools at lower speeds if possible to prevent overheating of the panel, which could cause damage, as well as wear out the abrasive of the cutting or drilling tool much faster. So the technician is making sure to focus on the weld itself, and this is technically considered a cross-cut method as demonstrated in our cross-cut and buff grinding video. So he's using the cutoff wheel with the thick disc in here to get these edges. This is a great way to get the edges in here without overgrinding or damaging the area around it, as the disc on here can focus itself on the weld. It's an important thing to know when to stop grinding, as we can easily overgrind the panel. So did the technician grind the correct amount or overgrind in this particular joint? We do not necessarily need to make what appears like a seamless panel at every one of our joints. What's important is to make sure that our joint maintains its strength and integrity first of all, and then if it is a joint that will be finished, can we finish the panel with some filler material? And that's what the technician is doing with the straight edge, is making sure that the panel is fillable, that there are no high spots. This demonstration here shows proper grinding from unground and overground, and here we can see that this is overground. There's too much material removed. That's correct in here. This is not quite enough material removed. You can see the teetering, and that would be unground, so none of the weld removed. Sometimes you can actually leave the entire weld on and not do any grinding in some circumstances. Here are the back sides of 3 plug welds. The one that was furthest from us had whiskers on the back side, and those whiskers can act as wicks, wicking up moisture, causing premature corrosion. Now the technician is going to start grinding this weld on the left, which is not a very pretty plug weld, with this belt grinder. The belt grinder is aggressive and will quickly take down the head of that weld. Note that with how aggressive the tool is, the technician is stopping before going too far, as it's very easy to overgrind with that. It's not a good tool to use for finishing your welding. Now he's switching to the wheel, in this case the cutoff wheel with the wider disc, to try and get into that bottom curved or corner section in that pinch weld joint. After he's done with that, he's going to move on to the angle grinder to finish off the grinding on his weld. Again, determining at which point he's able to stop. If you have a look at the other 2 welds, should the welds be ground, or can we actually leave a plug weld unground on a vehicle if it's not going to cause any clearance issues? The technician will have to determine which type of grinding disc to finish the grinding with. If you're going to apply a body filler material, perhaps finishing in a 50 or 80 grit disc would be acceptable. If you're going to proceed to the paint process, then finishing with a fiber disc like is seen here, or even sandpaper, may be a better option for the refinishing of that panel. Otherwise, sand scratches and grinder marks will show through. Any pinholes or other holes must be welded closed, and a light from the back side of the panel can help determine those locations. Filler should not be applied over any holes. We can see the technician is overgrinding here by that dark color we saw in the top corner. Not only is he overgrinding, he's removing a substantial amount of material, thinning the metal, which very substantially affects the strength of the panel, and we can see those dark spots over here. Here we see a conventional drill bit, spot weld drill bit, and this one here, which is a hole saw type drill bit, sometimes referred to as a rotor broach. And this one is going to cut like a hole saw around the weld rather than cutting the whole weld itself. This will leave a nugget behind afterwards. A problem with these tools, as you see right now, is the tool likes to float across the panel. So starting with a center punch or drilling the center of the weld with a 1/8 inch drill bit first can aid with fusing this process. This tool works very well in some areas and may work very well on harder to cut metals like high strength steel. Thanks for watching. If you like this, please check out our other videos on auto body repair.